Hi, this is Tom from Expat Hydroponics. This video is mainly a review video for the Yinmik 4-in-1 handheld tester I purchased online a few weeks ago. But I will also discuss nutrient density as measured by EC and ppm. I won't get too far into the weeds on this topic as it can be a complete video by itself, but I will also show you how to calibrate this meter for pH. Let's forego the normal introduction segment so I can give a quick update on the plants in my vertical tower. As you can see, most have survived the shock of transplant, but the regular cilantro plant doesn't look like it's going to make it. I moved the Italian cilantro away from the direct sun side and it's doing much better. The leaves are going back to green. I think the combination of high ppm nutrient levels, specifically nitrogen levels, and direct sun was causing tip burn. You can learn more about this and other plant maladies in the video above. Doing especially well are the eggplant, zucchini, cucumber, and tomatoes, all with significant growth after only 2 weeks. Above is a link to the initial setup. On to the review. I purchased the Yinmik 4-in-1 monitor online for $21.49 on Amazon. Yinmik specializes in water testing meters. They have more expensive meters that include Bluetooth connections and tests for other factors like oxygen levels. I'm on a budget, so I decided on this unit. Not the cheapest, but it tests for the 3 most important measurements for me: pH, temperature, and ppm. It also has a newly designed tougher probe and compensates for temperature. Both are important to me. I'll not get too technical in this video, but I will mention that there are 3 different conversion methods to convert electrical conductivity, or EC, to parts per million, also known as ppm. All of these types of meters measure electrical conductivity by passing a low voltage across 2 probe ends to measure resistance. Pure water is an insulator and therefore has high resistance and measures a 0 on the EC scale. The more dissolved solids there are, the more conductive the fluid and thus higher EC reading. This meter determines the ppm by dividing the EC level by 0.500. This is the standard for the United States. In Europe it is 0.640 and Australia it's 0.700. If this seems confusing, it's because it is. However, more significantly, the EC measurement will vary greatly depending on water temperature. The warmer water temperature will show a higher EC reading if your meter is not temperature compensated. The water temperature can change the EC reading as much as 100%. This meter compensates for the temperature in the EC, pH, and ppm conversion. This is why I use ppm when measuring nutrients. This may be slightly controversial as some people online only use the EC reading. I invite you to also listen to their reasoning and make your own decision. Okay, the unboxing is done. Let's calibrate the meter for pH and review the features at the same time. The meter is calibrated at the factory for ppm, so I will only calibrate for pH at this time. Let's start with the calibration for pH, and I will touch on a few of the features and functions along the way. A couple of tips before we start. This is for people like me that don't tend to read the instructions. First, set up 3 containers, in my case glasses, that can hold 250 milliliters of water. Distilled water is better, but you can use purified drinking water. 1 liter bottle is perfect. Next, the sequence in calibration is 7.00, then 4.00, and finally 10.01. Do not long press the mode cal button in the air. This may make the meter unusable. Do not take the device out of the solution until the calibration is finished. The pH number will stop flashing when finished. Lastly, rinse the probe between calibrations so you don't contaminate the other solutions. Step 1. Dissolve the packets of pH powder, 1 each, into the 3 containers of 250 milliliter water. In my case, I had to wait about an hour for the powder to completely dissolve. Step 2. Take off the protective cover, Rinse and then dry the probe before use. Press the on-off button to turn on the device and press the Mode Cal button to switch to the pH mode. Step 3. Put the device in the 7.00 pH solution. Shake to remove any bubbles. Let stand until the reading is stable, then long press the Mode Cal button when the device is in the solution. Long press means to hold the button down for 5 seconds and then release. Wait for the 7.00 to stop flashing and you're done. Okay, we start by rinsing it in purified water. Then we put it in here. Oh, it's ppm, so I need to change that to pH mode. Put in here. And then once it stabilizes, we hold this down for 5 seconds. 4,000, 5,000. It hits calc. And that should blink. And 7.0. Next, rinse the probe in the pure water. Go to the 4.00 solution and repeat the process. Finally, rinse the probe and repeat all in the 10.01 solution. It says that you can seal and save the solution for up to 60 days. I'll not do that. I have a teenage son that eats and drinks anything he can get his hands on. Extra probes and solution powder for pH and EC calibration solution is available online. My package did not include calibration solution, but the procedure is the same, only changed to EC mode. Also included is a copy of the instruction manual. It includes battery placement, probe replacement, how to measure and how to lock and unlock the measurement. If you're unfamiliar with these type of measuring devices, I recommend reading through this. Overall, I've been using this meter for about 3 weeks, and I'm very happy with the purchase. It has a large backlit display that is very easy to read, unlike the others that I've purchased. The build quality seems good, so it should outlast the other probes I've purchased. As a side note, on my recent trip to both Home Depot and Lowe's, not one person I asked in the garden section knew what hydroponics was, and almost all never heard of it. We need to spread the word. As usual, thank you for watching. Like and subscribe. God bless.